In this tutorial, I will explain local and global performance indicator for model performance assessment. When we build machine learning models, we usually evaluate them using performance metrics like root mean square error, mean absolute error, and R squared. These are what we call local performance indicator. They each tell part of the story. Root mean square error captures large errors, mean absolute error gives us the average miss, and R square tells us how much variance we have explained. But what happens when these metrics disagree? One model might have the lowest root mean square error while the other has a better R squared. So which one do we choose? That's where we shift from local to global performance thinking, looking at the model's behavior across all metrics, not just one. So now let's visit the code. Here you can see this code is written for the compromise programming. In this tutorial I am going to explain three techniques: compromise programming, TOPSIS, and VIKOR. So the first one is compromise programming. So compromise programming, it imagines an ideal model, the best possible score across all metrics, and then measure how far each real model is from that ideal. The closer the distance, the better the model. It is flexible and gives us a real sense of how perfect or imperfect a model is. You can even tweak how much you care about worst case versus average performance by using different distance formula. So this is the code. First import the main libraries, and then these are the statistical performance indicators values which I have got through LSTM, RNN, and CNN model training and testing. So this one is for the LSTM, this is the root mean square error, this is the mean absolute error, and this is the R square value. The second column is of the RNN and the third column is CNN. So now the data is basically uploaded to the data frame of the Google Colab, and now the R square is normalized by using minimum maximum scalar technique, and R square and what of R squared is considered to maximum minimize the objective age like the root mean square error and mean absolute error. So this piece of code is basically for this purpose. And now move to the third step, that is basically compute L1 and L2. You can check the formula of compromise programming for both training and testing. So this is the formula. You can check it from the literature. And after computation of L1 norm and L2 norms, now the models are ranked based on these computed L1, L2 norms, and then this fifth one is the final results. So when you run it, so the results are here. You can see root mean square, mean absolute error, and R square value. And this is the norm root mean square error, norm MAE, and norm R square phi. And this is L1 norm, and this is the ranking of L1 norm, this is L2 norm, and this is the ranking of the L2 norm. So here you can see that RNN stood first, and then LSTM is the second one, and CNN is the third one, the worst case. So now move to the next one, that is TOPSIS. So let me throw some light on this technique. So TOPSIS is the another technique for order preference by similarity to ideal solution. It works by choosing the model that's closest to the best and farthest from the worst. It's a balance between aspiration and caution. TOPSIS gives you a score between 0 and 1, and ranks model in a very technical way, which makes it especially popular when communicating results to non-technical stakeholders. So let's visit the code. Here you can see again I have imported the library, and this is basically the data, that is the statistical performance indicator, and this data is basically uploaded to the data frame. And here again this is the normalization of the data using minimum maximum scalar technique. And here this is the invert of R square, as root mean square error and mean absolute error are smaller. So basically 1 minus R square is also minimize the objectives. So now apply the code. Initially the weight are considered similarly, and the normalized value are basically multiplied by the weights. So here you can see minimum and maximum identify ideal and anti-ideal solution by what? By considering the minimum and maximum value. Here you can see this is the minimum and this is the maximum. So minimum is the ideal and maximum is the anti-ideal or worst case scenario. And now compute the distance. Here you can see, you can check this formula from the literature. This formula, it will compute the distance to the ideal and anti-ideal cases. And same here is, you can also check this formula from literature, where you can see distance to anti-ideal divided by distance to ideal plus distance to anti-ideal. So this is the formula which you can find from the literature, and these results are basically uploaded to the data frame, and then again this is the score is computed, and this is the result. So here you can see RNN, LSTM and CNN. Here TOPSIS score is calculated 1, 0.62 and 0.00. So basically RNN is again stood at first and followed by LSTM and then CNN. So now again come to the next one, that is VIKOR index. So let's throw some light on this first. So basically VIKOR, this technique focuses on compromise and regret. It looks at two things: how well a model performs overall and how bad its worst metric is. VIKOR does not let a model slide just because it's a good on average. It punishes model with glaring weaknesses. It's great when you are in high stakes domain like healthcare, finance, where one bad metrics can mean real world consequences. So now let's again visit the code. Here you can see again I have imported the libraries. This is the statistical performance data which I have acquired from LSTM, CNN and RNN model training and testing, and this data is uploaded to the data frame of the Google column. Again the same thing is adopted. The data is normalized by using minimum maximum scalar, and R square is maximized, so we use 1 minus R square to minimize it. So now again invert R square. So this is basically invert 1 minus norm R square. So again we have considered same weight for all the three, and then minimum and maximum for F star and F minus. Here F star, this is F star and this F minus. So this is basically the minimum maximum of these two. So now compute SI and RI. These are the formulas which you can find from the literature. So this is the formula, and again this formula continues. So we will compute SI, RI, and this which will be used for the computation of Q. So here for the computation of VIKOR index we have adapted the value of V0.5. You can also check this value or use this value as per the literature. So for this formula, all these formula you can check literature and then you can use it, these whole formulas. And this SI and RI value is utilized for the computation of Q. and again this store, it will store the S, R and Q values, and finally the result are displayed. Here you can see root mean square error, mean absolute R square, these are the same value which we have given it initially, and this is the VIKOR S value, VIKOR R value and VIKOR Q value. So based on this, VIKOR rank is calculated. So again RNN stood first, followed by LSTM and CNN. So the result of these three model for the same data is consistent. So this is all about this tutorial.